Now today we're going to talk about the impossible and the future. With Arthur C. Clarke. It was Arthur C. Clarke, who just passed away, who said that any sufficiently advanced technology is indistinguishable from magic. So let's talk about the future. When might these technologies become possible? First of all, let me quote from that great philosopher of the Western world, Yogi Berra. Yogi Berra once said, "Prediction is awfully hard to do, especially if it's about the future." Well, we physicists invented the past. We invented the transistor, we invented the laser, the internet, we wrote the World Wide Web. We created radio, television, microwaves. Most of what you see around you was created by a physicist. Well, when we helped to create the internet, we made a prediction that the internet would one day become a form of high culture, high art, and high society. Well, today we know that 5% of the internet is pornography. But that's because teenage boys log on to the internet. Just wait till the grandmas and grandpas log on to the internet. Then 50% of the internet could be pornography. So let us talk about the impossible. And I will try to tell you that we are making so many inroads into the impossible that there are very few things which I think are truly impossible. Let's look at the history of the impossible. During the Victorian era, Lord Kelvin of the Kelvin scale was enshrined in Westminster Abbey, right next to Isaac Newton. He's buried right next to Isaac Newton. He's famous for making many predictions, all of which were wrong. He predicted that airplanes were impossible. He wrote about the impossibility of airplanes. He said X-rays, were a hoax. Radio, who needs radio? How old is the Earth? It was impossible that the Earth could be older than just a few million years. And we also had Robert Goddard. Let's go back. Robert Goddard, the New York Times, thought that the father of rocketry was wasting his time. The New York Times flailed at Robert Goddard, saying that rockets are worthless because rockets cannot move in outer space because there's no air to push against in outer space. Well, the New York Times, unfortunately, had no hot air to push against, and Goddard was right. And even Rutherford, father of the nucleus, thought that the atomic bomb was, quote, moonshine, never possible, and even Einstein thought that black holes, they may exist, but they couldn't form naturally by the condensation of gas. He was also wrong about his own creation. So let's talk about these things. I like to categorize them as Class 1, Class 2, Class 3. Class 1 impossibilities include ray guns, force fields, invisibility, teleportation, starships. They're going to be possible within a few decades. In fact, I'll show you videos of the first experiments on invisibility and teleportation. Class 2, well, that may take centuries to achieve, but that may also be possible. Time machines, faster than light travel. Class 3 are simply downright impossible. Perpetual motion machines, precognition. Every once in a while, the Wall Street Journal emails me about yet another inventor who is making millions of dollars selling a perpetual motion machine. And they want to know my opinion. I usually email back a quotation from P.T. Barnum, which says, quote, "There's a sucker born every minute." So let's talk about these things. First of all, let's talk about invisibility. You know, I teach optics at the university to physics majors, and I teach them that invisibility is impossible because it violates the laws of optics. In fact, every physics book in the world, when discussing optics, says that invisibility is impossible. Well, I was wrong, and so was every single physics textbook in optics. So, invisibility is no longer science fiction. A few months ago, just a few months ago at Caltech, University of Karlsruhe in Germany, and Ames Laboratory in Iowa. They were able to make red light and green light bend in a way compatible with invisibility. This means that within a decade, we may have full invisibility for one color. One color, an object will disappear. A few more decades, the primary colors. We will have an object disappear on the primary colors. And after that, Harry Potter, watch out. Well, this is the material that does it. It has impurities. When we teach optics to our students, we talk about glass, we talk about diamonds, we talk about air that are uniform. Metamaterials are not uniform. That's what we miss. These are impurities. Impurities that kick the light beam so that it flows around an object. This is how it works. If I have a boulder in a stream, the water flows around the boulder and then reforms at the other end. If you're downstream of the boulder, you do not know there's a boulder upstream. So this is the secret of invisibility. This is what we missed. This is why every physics textbook in optics is wrong. Whole new chapter has to be written because, like I said, in a few decades, we'll make objects disappear. And now let's talk about that fantastic device that you see on Star Trek. Is it possible that one day we can disappear and reappear someplace else? Well, we have something called quantum teleportation. At the atomic level, we can do it. That doesn't mean we could do it for Captain Kirk. But at the atomic level, we have already done it. So in the next video, you will actually see the world's first teleportation device. It does not look like what's on Star Trek, but this one works. By the way, in Star Trek, Roddenberry originally had the crew landing and taking off in rockets. But Paramount Studios says, that costs too much. We want budget cuts. So they cut out the rockets, and they had Captain Kirk beam down to the planets. That is the origin of teleportation. Budget cuts at Paramount Studios. So then the question is, how far can we push artificial intelligence? Will we really have robots in the home? Well, first of all, let me let you in on a dirty secret. Why is Japan spending so much money on robots? Why millions of dollars on robots? Well, let me let you in on a secret. The Japanese population is the fastest aging population on Earth. They have a very small birth rate, 1.2 children per family. These are the future robot nurses. Japan has almost no immigration. With no immigration, with an aging population, who's going to take care of all the old people? Robots. That's why they're investing so much in robots. And who's next? Europe. Europe is next. Italy has a birth rate of about 1.3 children per family, and Italy is a Catholic country, for God's sake. So then the question is, why don't we have robots? Well, I went to MIT, and I talked to the top people. And I said, well, why don't we really have robots that you can talk to and gossip with? And they told me something interesting. They said there are two reasons why we don't have robots. The first is pattern recognition or eyesight. When you walk into a room, you scan objects, you understand there's a table, chair, podium. When a robot walks in the room, it sees lines, pixels, circles. It doesn't know what anything is. If a robot sees this, it'll say, well, this is a line, it's another line, it's a cylinder. They don't know what this thing is. It takes them 6 hours to walk across the room. 6 hours to walk across the room. Can you imagine a Terminator robot taking 6 hours to walk across the room? Can you imagine the governor of California taking 6 hours to sign a bill? That's the first reason. The second reason is common sense. Now, you know that water is wet. You know that when you die, you don't come back the next day. You know that mothers are older than their daughters. You know that strings can pull, strings cannot push. You know that sticks can push, sticks cannot pull. Now, here's the question. How did you know that? how did you know that strings can pull but not push? How did you know that animals do not like pain? How did you know that sticks can push but sticks cannot pull? Why? That's common sense, right? Well, that's exactly what robots do not have. So we now know what the job market of the future is going to look like. Jobs of the future will be those jobs that robots cannot do. For example, garbage men will have jobs because every garbage is different. Construction workers will have jobs because every construction site is different. Who won't have jobs? Auto workers, because every motion of an auto worker is pre-programmed and can be replaced by a computer. Who else will have jobs in the future? Common sense jobs. What is common sense? Creativity, artwork, telling a joke, telling a story, making people laugh, analysis, software, mathematics, science, leadership. That is common sense. And now let me tell you the bad news. This is really bad news. In the future, we will also have lawyers. Horrible, absolutely horrible. Well, every lawsuit is different. Every lawsuit requires value judgments. That changes with time. That requires common sense. So robots, this robot is pre-programmed. How intelligent is it? It's like a tape recorder. It is as intelligent as a cockroach, a stupid cockroach, a lobotomized, retarded, stupid cockroach. You know that scene of me and Asimov? It took 5 hours. 5 hours to get that scene right. That's how primitive our robots are. Okay? They are bug bots. They have the intelligence of a bug. Now that doesn't mean that in the future they can't be intelligent. It's just that artificial intelligence turned out to be a lot harder than we thought. A lot harder than we thought. Now what about emotions? Well, we all know the Tin Man. The Tin Man wanted a heart. And Data from Star Trek, he wants to understand a joke. So are emotions really important? Well, now we realize that emotions really are important. Because, well, there is a brain problem where if you're in a car accident or you have a stroke, sometimes the front part of your brain, which governs reason, is disconnected from the inside of your brain, which governs emotions. These people are not emotional because the link is broken because of disease or an accident. Now, when you talk to these stroke victims and these accident victims, and you ask them to make a value judgment, should I see you tomorrow? What do you want for dinner tonight? What kind of clothes do you like? What kind of color do you like? They are paralyzed, absolutely paralyzed. Every color is the same to them. Rich things, poor things, expensive things, beautiful things, pretty things. Beautiful has no meaning for them. Ugly has no meaning for them. They have no emotions. In other words, they're paralyzed. You can't go shopping with these people. You go shopping, you see things that are expensive, pretty, bright, fashionable, ugly. It's all the same for these people. In other words, we need emotions. The purpose of emotions is so that we are not paralyzed by all these decisions. And this is now what we're beginning to realize. We want our robots to be emotional. Now, can they be dangerous? Here's the governor of California. Take that. Well, yeah, they could be dangerous. Maybe in the future they'll be as smart as a rabbit, maybe as smart as a dog. And when they become as smart as a monkey, I think we should put a chip in their brains to shut them off if they have murderous thoughts. Another possibility is to merge with robots. When robots become really smart, why not become immortal? Why not become Superman? Why not merge with robots and live forever? Now you may say to yourself, well, that's ugly. I mean, who wants to wake up in the morning and find out that you're inside a robot's body? Well, if the choice is either you die or you live forever as an enhanced Superman, what choice would you make if you were old? Live forever or die? Now let's talk about what I do for a living, which is the very cutting edge of space and time. Time machines. Is it possible First of all, some people say time machines are not possible because where are the tourists from the future? My friend Stephen Hawking says, well, they're not taking pictures of me, so where are the tourists from the future? Well, let's talk about time travel. First of all, where are the tourists from the future if time travel is possible? Well, they must be very advanced. First of all, if you're walking down a country road and you see an anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, take me to your leader? Or do you step on them? Tourists from the future are so advanced, so far ahead of us, that we would be like ants to them. So they may not want to visit us. Next question. What happens if you go back in time and meet your teenage mother before you're born, and she falls in love with you? How can you be born if your teenage mother just fell in love with you and rejected your father? Wow, big trouble. So how would we do this? Well, perhaps a wormhole, perhaps a passageway through space and time. This, of course, would require fantastic amounts of energy that I mentioned before. This is not for the average person. This is not something that we can create anytime soon. However, the wormhole is Alice's looking glass. Think of the looking glass of Alice. You put your hand through the looking glass, and you wind up on the other side of forever. That's a black hole. Usually we think of a black hole as being a dot of infinite energy called singularity. But that assumes the black hole is stationary. We have photographed black holes. They're all spinning. According to the theory, spinning black holes collapse to a ring, not a dot, spinning so rapidly that centrifugal force keeps it afloat, doesn't collapse. If you put your hand through the ring, you are Alice going through the looking glass. In other words, a black hole could be a gateway. Of course, there are many problems with this: radiation, gravitational fields, so on and so forth. But mathematically, a black hole could become a gateway. Now let's talk about who is out there in outer space that may have this fantastic power. Let's talk about aliens from outer space. First of all, when we physicists look in outer space, we look for signals from intelligent civilizations in space. We look for, not green men, we look for type 1, type 2, type 3 civilizations. A type 1 civilization is planetary. They control the weather. They control volcanoes. They control everything planetary on their planet. It's about 100 years in the future for us. Type 2 is stellar. They control the energy of a star. Type 3 is galactic. They control the energy of an entire galaxy. This is what we physicists look for when we scan outer space looking for civilizations. Now, on this scale, what are we? We're type 0. We're not even on the radar screen. We get our energy from dead plants, oil and coal. But we can dream about being a type 1 civilization. This is what a type 1 civilization may look like. Planetary. Every form of planetary energy they control. The weather, earthquakes, volcanoes, hurricanes, about 100, 200 years ahead of us. They have colonized the nearby planets. They even mine the asteroid belt, a type 1 civilization. And believe it or not, we are witnessing the birth of a type 1 civilization. We are privileged to be alive, to witness the greatest transition so far in the history of the human race, a transition to type 1. What will a type 1 civilization speak? They will speak English. English will be the language of this future type 1 civilization, not French. What is the internet? The internet is the beginning of a type 1 telephone system. We are privileged to be alive, hold on a second, to witness the birth of a type 1 telephone system. I can't even get this laptop to work right. You see, we really are a type 0 civilization here. Well, you'll have to use your imagination. A type 2 civilization is immortal. They can survive even the death of their mother star. That's a type 2 civilization, like Star Trek. Star Trek and the Federation of Planets is a very typical type 2 civilization. They control a star or two. They're like the Federation of Planets. However, there is something as type 3. Now, for those Trekkies out there in the audience, can anyone tell me the name of a type 3 civilization on Star Trek that eats type 2 civilizations for breakfast? It's a rapacious, ravenous, galactic civilization on Star Trek. What is the name of that civilization? No, not the Borg. Very good. We have some Trekkies out there, true blue Trekkies. It is the Borg. They will have probes, von Neumann probes, that land on moons, make copies of themselves, millions of copies, and just like in 2001, colonize the universe. They will have atom smashers. They'll be able to play with the fabric of space and time, perhaps even create a baby universe by which they may be able to leave our universe, go to another time, go to another place in the universe. Now, I was giving this talk in London a few years ago, and a little boy comes up to me, 10 years of age. He tugs on my pants, and he says, "Professor, you're wrong. There's type 4. I looked down at the kid. This little kid, you know, tugging on my pants. I looked down on him, and I said to this kid, "Shut up, kid. Why don't you go play in traffic? There's a nice intersection over there." I told this kid, look, there are planets, stars, and galaxies. That's it. Planets, stars, and galaxies. Type 1, type 2, and type 3. And then the little kid said, "No, Professor, there's type 4. Well, who in this audience can tell me the only type 4 civilization on Star Trek? No? What is the only type 4 civilization on network television? The Q. Very good. Now, if you did not understand what just transpired in the last 10 minutes, get with the program. It's on channel 11. And you can watch the Q. What is their energy source? Dark energy, which we now know is the energy of the vacuum. Who would have thought that the energy of the vacuum would be the largest source of energy in the world? Dark matter also exists. Invisible matter. This is incredible. Every textbook on Earth is wrong. We now know that most of the universe is dark. Now, there's also a sad story behind this. There was a woman, Vera Rubin, who first discovered dark matter, but she was laughed at because people said, "You are a woman astronomer," and we don't believe in them. Well, the worst story was even worse than that. In the 1960s, a woman graduate student, Jocelyn Bell, saw a star blinking at her, and she carefully logged it down day after day, cold day after cold day, week after week, wrote down a blinking star. Then she made the biggest mistake of her life. Jocelyn Bell said to her thesis advisor, "Come on over and take a look." Well, the thesis advisor took one look and said, "Oh." So when it was time to write up the paper and all the painstaking data, whose name came first? The professor's name. When it was time to give talks around the world, who gave the talks? The big shot professor or a lowly female graduate student? The big shot professor. And when it was time to win the Nobel Prize in Physics for the discovery of the pulsar, who won the Nobel Prize in Physics? He did. What's the lesson? The lesson is, if you ever make a big discovery, tell me first. I'm a generous man. I'll give you a subway token, you know, some kind of recognition. But, you know, if you're just a lowly member of the public, I'm the big shot professor. Well, let me just end on a few last notes. As my friends tell me, who work on this professionally, our Earth also radiates into space. There is a sphere surrounding the Earth. It is 50 light years in radius, because we've been broadcasting for 50 years, and it's expanding at the speed of light. This sphere contains the finest of our cultural archives, the noblest achievements of the human creative spirit, like I Love Lucy, Leave It to Beaver, and now joined by the immortal classics, Beavis and Butthead, and Dumb and Dumber Part 2. Any star within that sphere will pick up our cultural emissions, and they'll be convinced there is no intelligent life on the earth. Thank you very much. Thank you very much. And we have time for a few questions that you can make as hard as you want, the questions. And then I'll sign some more books. And I'm also proud to announce that Physics of the Impossible is now 18 on the New York Times bestseller list. It made the New York Times bestseller list. They used to say that physics books don't sell. Well, here's one that actually hit the New York Times bestseller list. It just happened yesterday. Okay, in the back.
Yes, I'm a physics teacher. I'll make sure I buy a few copies for my kids. You mentioned type 1 technology, and I think that's our best hope right now. And I love your story, Don't Tell the Boss, because that's relevant to my question. It seems that all technology was crafted by people who don't end up deciding how it's configured, which the last I checked is true now, that scientists, we used to call them natural philosophers and engineers, make these wondrous things, but our rulers are the ones who make the decisions for how they're used. And it seems to me that instead of having sails across space, which only the super rich would be afford to take a trip on, we need something the average person, who you mentioned, my important category, the average person, that's what I am, most of us in here, maybe make sails across the ocean. So that me and Tim, we want to go to Crete for a physics conference. We don't have to add to global warming. We can sail across the ocean. So what I want to know, Professor, is how do we deal with that problem of who do we, the people, have the power to decide our future, or are we just going to let George Bush or even Obama, who I'm voting for, or whoever, make the decisions with the experts that they hire rather than you and laymen like me? Well,
okay, well, there is some hope. You know, the internet was originally created not by a bunch of teenagers, but by the United States Pentagon. It was called ARPANET, and it was designed to fight a nuclear war. Why is your email chopped up and then reassembled at the other end? Because in case of a nuclear war, Los Angeles is destroyed, San Francisco is vaporized, and your email has to be broken up to bypass all the vaporized cities. That's why your email has this circuitous route. So the internet was mail, a male-dominated machine. Then in 1989, with the Soviet Union breaking up, the National Science Foundation simply gave it away. Just gave the whole thing away because there was no more use for it. Now the internet is basically female. It is about touching people, contacting people. And 1984 might have been possible before 1989. But now it's too late. If the President of the United States were to ban the internet right now, people would laugh at him. You cannot ban the internet. It is everywhere and nowhere. And the problem is not Big Brother. The problem is little brother, nosy busybodies. Now, because we have the internet, we can organize, we can make our voices felt. It's a democratic thing, like in Burma. What was the first thing that the Burmese military junta, what was the first thing they did when riots broke out a few months ago? They tried to shut down the internet. They knew that the truth had to be controlled. In the future, in your wristwatch, you will have full internet capability. You'll talk to satellites. And it will be impossible for any dictator to hold the truth unto themselves. Now let's be clear about this. Technology is a sword. It's a double-edged sword. One side can cut against disease, ignorance, and poverty, and can really give us a type 1 civilization. However, there's a second side of the sword. The second side of the sword could also cut against us unless we are educated and we understand the power of this technology. There's some people, by the way, who instinctively do not want this march to a type 1 civilization. A type 1 civilization is tolerant, multicultural, because it is planetary, and it is progressive and scientific. The people who don't like it are the terrorists. That's why terrorism is so appealing to people, because for some people, they don't like modernism. Modernism means tolerance, multicultural, other cultures interacting with other cultures. And hey, that's a type 1 civilization. And that's where we are headed. Every headline in the newspaper I see points to the beginning of a type 1 civilization. English will be the language of type 1. The European Union is an example of a type 1 economy. Why does the European Union exist? These European countries hate each other. England, Germany, France. They launched 2 world wars and killed about 100 million people. How come they band together to form the European Union? Because they're competing against us. And who is us? We are NAFTA. So we're seeing the beginning of a type 1 economy. We're also seeing the beginning of a type 1 culture. You can go anywhere on the planet Earth and show people pictures of a man and a woman, instantly recognizable. Who are they? Arnold Schwarzenegger and Madonna. My God. We now know what this type 1 civilization's culture is going to look like. It's going to be rock and roll. It's going to be blue jeans. It's going to be rap music, high culture, youth culture. That's what this planetary culture is going to look like. Soap operas. Hey, you know, it's coming. So anyway, what I'm saying is, well, the internet empowers us. It is a vehicle by which we can organize, we can get our voice out there. But it was once an instrument of war. Another question? Yeah?
This always bugged me. I want to see your take on it.
Please stand up. We can't hear the question.
Yeah, sure. If we assume there are alien civilizations out there and that they likely use the von Neumann machines to explore and be exponential in growth, why haven't we seen any of them?
They're probably here, on the moon. We told Kubrick, before he made 2001, that perhaps our moon is the most likely place where a passing Type 3 civilization left a von Neumann probe. But we're too primitive to make contact with it. To make contact with that probe, you have to be Type 1. A Type 1 civilization has a colony on the moon. And if you saw the movie, they touch the monolith and it sends a signal to the home planet. We're not Type 1 yet. Arthur C. Clarke was off by maybe 100 years. It shouldn't have been 2001. It should have been 2101. He was off with artificial intelligence, and he was off with having colonies on the moon. My attitude is, if you want to look for aliens and alien technology, perhaps the best place may actually be our moon. It is stable, no erosion, no rust, it lasts forever. Maybe on our moon there is a passing probe left by a passing Type 3 civilization just waiting for us to become Type 1 when we become interesting. If we're Type 0, we're not very interesting to them. But a Type 1 planetary civilization with planetary culture, science, and art, we'd be quite interesting to them. I think we're simply ants that are not that interesting to them yet. Yeah?
I wonder if you're familiar with John Kramer's retro causality experiment?
No. No.
Well, I guess you can come.
Oh, sorry. Yeah?
I was wondering what you think about Stephen Hawking's theory about the loss of information when black holes evaporate. And, he's changed it a bit, but if there are miniature black holes, what's your opinion on that?
Yeah, Stephen Hawking said that if I get the Encyclopedia Britannica and throw the Britannica into a black hole, all that information is lost forever. Now, of course, every school kid would love that. You throw the library inside the black hole, it's gone. It's gone forever. But we physicists think that's a disaster because information is never lost. It winds up somewhere, but it's never lost. So Hawking said, I want to bet you. I'll make a bet. I'll bet you that it is lost forever. I'm a quantum physicist. In quantum physics, nothing is ever lost. You never lose anything. Well, we hammered at him, and about 3 years ago, he gave up. He said, I was wrong, you guys are right, okay? I'm a string theorist. In a string theory, we never lose information. So what happens? You throw the encyclopedia in, but then, poof, it glows. The black hole glows with Hawking radiation, and the glowing vibrates. And the glowing vibration contains the Encyclopedia Britannica. So you never really lose it totally. So yeah, Stephen said he was wrong. He also said time travel is impossible because I don't see tourists from the future. He proposed the chronology projection hypothesis, stating that time travel should be outlawed by a law of physics. He looked for it. He gave up. And he finally said that time travel is possible because he cannot disprove it. So we think that time travel is possible. Not practical. You have to be type 3 before you can play with these black holes. But yeah, maybe possible. So Stephen is so up there, so prestigious, that he can say, I'm wrong, and get away with it. A lesser physicist may be crushed, but he can say, yeah, I was wrong. Oh, one more question and we'll wind up, and I'll sign more books. And you know, if I want pictures taken, I'll do that too.
I was interested in the quantum teleportation bit that you had there. Does this violate the, I'm interested in the speed of the transmission. When you exchange this data on the photon, is this violate simultaneity, or is it happen at the speed of light like a normal radio wave? Or a light wave?
Excellent question. The information transfers at faster than the speed of light. Now, Einstein hated this concept because you can't go faster than the speed of light. But we've done this experiment. We've done it. It goes faster than the speed of light. So was Einstein wrong? And the answer is no. Einstein had the last laugh. It turns out that the information that is transferred, that goes faster than light, is random information, useless information. So if you know that this photon is pointing up, the partner photon, the partner, should spin down. The two add up to give 0, right? So as soon as you know that this photon is spinning down, you immediately know that's spinning up. But can you send Morse code that way? And the answer is no. Let's say you have a friend who puts on a red sock and a green sock, but mixes it up. One sock is red, one sock is green. Well, one day you lift his pants and it's green. Instantly, faster than the speed of light, you know that the other sock is red. Now, did you violate relativity? No, because no usable information was transferred. So you can go faster than the speed of light if it's useless information. So Einstein has the last laugh. These quantum experiments that you saw, they use photons traveling less than the speed of light. Okay, so they don't break the light barrier. But information does go faster than light, but it is random. The non-random information, which is usable, travels less than the speed of light. Now today we're going to talk about the impossible and the future. It was Arthur C. Clarke. It was Arthur C. Clarke, who just passed away, who said that any sufficiently advanced technology is indistinguishable from magic. So let's talk about the future. When might these technologies become possible? First of all, let me quote from that great philosopher of the Western world, Yogi Berra. Yogi Berra once said, "Prediction is awfully hard to do, especially if it's about the future." Well, we physicists invented the past. We invented the transistor. We invented, tell you that we are making so many inroads into the impossible that there are very few things which I think are truly impossible. Let's look at the history of the impossible. During the Victorian era, Lord Kelvin of the Kelvin scale was enshrined in Westminster Abbey, right next to Isaac Newton. He's buried right next to Isaac Newton. He's famous for making many predictions, all of which were wrong. He predicted that airplanes were impossible. He wrote about the impossibility of airplanes. He said X-rays, were a hoax. Radio? Who needs radio? How old is the Earth? It was impossible. They may exist, but they couldn't form naturally by the condensation of gas. He was also wrong about his own creation. So let's talk about these things. I like to categorize them as Class 1, Class 2, Class 3. Class 1 impossibilities include ray guns, force fields, invisibility, teleportation, starships. They're going to be possible within a few decades. In fact, I'll show you videos of the first experiments on invisibility and teleportation. Class 2, well, that may take centuries to achieve, but that may also be possible. Time machines, faster than light travel. Class 3 are simply down the laser, the internet. We wrote the World Wide Web. We created radio, television, microwaves. Most of what you see around you was created by a physicist. Well, when we helped to create the internet, we made a prediction that the internet would one day become a forum of high culture, high art, and high society. Well, today we know that 5% of the internet is pornography. But that's because teenage boys log on to the internet. Just wait till the grandmas and grandpas log on to the internet. Then 50% of the internet could be pornography. So let us talk about the impossible. And I will try to tell that the Earth could be older than just a few million years. And we also had Robert Goddard. Let's go back. Robert Goddard, the New York Times, thought that the father of rocketry was wasting his time. The New York Times flailed at Robert Goddard, saying that rockets are worthless because rockets cannot move in outer space because there's no air to push against in outer space. Well, the New York Times, unfortunately, had no hot air to push against, and Goddard was right. And even Rutherford, father of the nucleus, thought that the atomic bomb was, quote, moonshine, never possible, and even Einstein thought that black holes